In today's video, we're diving into our first capture the flag machine on the channel by stepping through how to exploit Cap from HackTheBox. If you don't know what HackTheBox is, they are a platform for practicing cybersecurity skills through challenges like capture the flag, as well as a learning platform for both red team and blue team positions. I'm not sponsored by HackTheBox, but I do really like their platform. It's where I learned a lot of my technical skills and my pen testing methodology. So I do recommend you check them out if you haven't already, especially if you want to get better at capture the flags or pen testing. The cap machine on HackTheBox that we'll be exploiting in this video is an easy level difficulty running the Linux operating system. Later on, we'll be exploiting an IDOR vulnerability or insecure direct object reference vulnerability, as well as a little bit of Wireshark PCAP analysis to gain a foothold on the machine. And then we'll be escalating our privileges to root through a Linux capability to own the machine. If you don't know what any of that is, that's okay, because it'll be explained a little bit more in detail later on in the video. So without further ado, let's get into it. And before we get started, if you don't already have a Kali machine or other virtual machine to connect to the HackTheBox network with, you can watch this video that I made to get that all set up. First things first, let's connect to the HackTheBox network through our VPN, and then spawn our machine on the HackTheBox website. Once the machine spawns, we see that we get an IP address of 10.10.10.245, so we can go ahead and copy that. To make our lives a little easier, I'm going to take the optional step of putting this IP address in my etc host file and giving it the name of cap.htb. This is basically going to resolve the domain cap.htb to our IP address of 10.10.10.245, so it's easier to remember, and because I'm pretty lazy and don't want to type in that IP address every time I want to reference the machine. So after we save our etc host file, if we go to our terminal and do a ping cap.htb, hope if I spell ping right, we'll see that the machine is pingable and we are good to go. And now we can move on to our initial enumeration. We're going to be creating and downloading quite a few files throughout the video, so I recommend with every capture the flag that you do that you should create a subdirectory to organize the files that you download. So for the purpose of this video, I'm going to save everything to my home CTF's demonstration cap subdirectory. And then within here, I'm going to make a new directory called scans. My first go-to NMAP scan that I do when I don't know anything about the device is this one here. Basically what this is going to do is scan every single TCP port, and it's going to save the results to my scans directory under the name nmap-all TCP. And if you didn't do the name resolution for cap.htb in your host file, you just put the IP address of the machine here. Once all of the TCP ports are scanned, we see that we have port 21, 22, and 80 open, which are FTP, SSH, and HTTP respectively. So we've got a file transfer server, an SSH server, and a web server on this device. We can enumerate these ports a little further to see the services and versions running on those ports by running this command. Basically, we're using nmap to scan ports 21, 22, and 80, which we previously found. And the -sc argument is going to use basic scripts to enumerate those ports. And the -sv argument is going to look for service names and service versions for those services. So we can hopefully find some easy misconfigurations or some really out-of-date service versions that we could potentially exploit. Once this scan finishes, we see that port 21 is running VSFTPD 3.0.3, which after doing a quick Google search does not seem to have any glaring vulnerabilities with it that we can use to get away in. There also does not appear to be any anonymous login enabled, so no free method of entry this way. Port 22 is running OpenSSH 8.2p1, which again does not provide us with an easy way in, which brings us to port 80, which appears to be running a Gunicorn HTTP web server. So let's take a look at that web server in our browser. When we visit the page, we see what looks like a security dashboard, and it looks like we're logged in as the user Nathan. So the first thing that I did when I first saw this page was see if I could do anything as the Nathan user. But clicking through these drop-down messages, settings, and logout appears to do nothing. So then I diverted my attention over here to the left on this drop-down here. And here we have 3 other tabs other than this default dashboard homepage. Clicking this first security snapshot one brings us to what looks like a packet capture file that we could download. If we click this download button here, we have the ability to download a packet capture file. If we click ipconfig next down on the list, it looks like a page that just gives us the results of an ifconfig command. And then the network status page does the same thing except for netstat. Neither of the ipconfig or the network status output is really useful to us. except for letting us know that there aren't really any other internal services running on the server except for DNS. My initial thought was we'd be able to pull off command injection with these 2 pages, but it doesn't appear that there's any way to enter in our own arbitrary commands, so I'm going to divert my focus back to the security snapshot. So based on the name of the tab here, it sounds like network traffic is being recorded, and every 5 seconds a PCAP file is created and posted on the page here. If you'll notice at the top of the URL we see data/7, and if we click this again, we are now on data/8. If we were to click it one more time after waiting 5 more seconds, we are on data/9. So it does appear to be recording network traffic on the system and uploading the PCAP files and sequentially adding a new page every time this is done. So this is where we may be able to abuse an insecure direct object reference vulnerability to access a packet capture that we maybe shouldn't normally be able to see. So if we type 1 here in the URL to go back in time to potentially the first packet capture, we see that the page does resolve, except there's no data on this packet capture. So we can move on to 2, and we see that there is some data here that we could download and analyze. So let's go ahead and do that. So after downloading that PCAP file to our system, we can go ahead and open Wireshark. And we can open that file in Wireshark. And that second PCAP file just appears to have some TCP connections from our machine to the CAP machine. It's all just TCP traffic over port 80, so nothing really useful. If we go back to the site and continue down the list, we see that Capture 3 has nothing. Capture 4 has 4 packets, which likely isn't anything. Capture 5 has nothing. Capture 6 has nothing. So instead of going forward in time, what if we instead tried to go to packet capture 0? Well, here we see a much larger PCAP file with 72 packets in it, which sounds promising. So let's go ahead and download that. And again, we can open it up in Wireshark. And if we analyze this packet capture, again, we see some TCP and HTTP traffic from 2 internal addresses. But if we scroll down a little bit, we start seeing some FTP traffic, and we can see some requests and response for FTP authentication, which is done in clear text. So we can go ahead and right click on any of these FTP packets, hover over follow and select TCP stream. And here we can see the entire FTP session that's been built out for us. What's in blue is going to be the server side, and what's in red is going to be the client. So looking at this packet capture, we see that we have the user Nathan with his password logging into FTP successfully. So let's copy down these credentials into our notes and see if they work on the system. So back on our terminal, if we try to connect to the server over FTP using the Nathan user, and we enter in that password that we found in the packet capture, we see that we get a login successful. So we know that the credentials work for FTP, and if Nathan uses the same password for his FTP login as he does for SSH, we may be able to use this to get a foothold on the server. So let's go ahead and try that. Using the command /nathan at cap.htb. Using that same password, we are in. And then in the home Nathan directory is where we'll find our user flag. So you can go ahead and type that out and paste that into your HackTheBox submission. Now let's see how we can go from the user Nathan to root to really show that we have full control over this box. So my Linux privilege escalation methodology pretty much follows everything in HackTheBox's Linux privilege escalation module. So if you're looking to learn more about Linux privilege escalation and you haven't looked at this module yet, I highly recommend doing that. So we're going to go down the list starting with all the easiest stuff first. So the first thing I like to try is sudo-l. This is basically going to list out all of the commands that the Nathan user can run as sudo. And unfortunately, Nathan has no commands that can be run as sudo on this server. So the next thing I like to try is looking for SUID binaries that can be exploited with GTFO bins, or maybe some custom SUID binaries that we could try to exploit ourselves. And if you want to learn more about SUID binary exploitation and GTFO bins, you can go ahead and watch my video that I made on that. But this command here is basically going to look through the entire file system and look for any binaries that have the SUID bit set. So here we get a full list of the binaries with the SUID bit set. And unfortunately, looking through this list, it looks like these are not going to be exploitable. And we can do the same thing for the GUID bit. And again, nothing exploitable. Another thing we can try is the ID command, which is just going to tell us what our user ID and group ID is and what groups we're a part of. And again, it looks like we're not a part of any special groups or anything like that, so no dice here either. Another thing I like to do is look at the etc passwd file, just to look for any other users on the file system that we may be able to take a look at and see if they have any credentials on the server. But again, it looks pretty basic. Doesn't look like there's any other user profiles, and it's just service accounts, so nothing looking too fruitful in this list either. Another thing to look for is cron jobs with weak permissions. Cron jobs is basically the Linux equivalent of scheduled tasks for Windows. So we can look for any scheduled jobs by typing in cat etc cron tab, and it doesn't look like there's any cron jobs that are set to run that we can abuse. Another thing that I like to do is run the linps.sh script in the background while I'm looking for other things manually. This is basically a script that looks for common privilege escalation vectors on the system and prints it out in a nice colorful output that makes it easier for us to look through. I have a copy of linps saved in my toolbox here, so I'm going to go ahead and copy that over to the machine using SCP. So this command is just copying this linps-base.sh file over to the home Nathan directory on the cap server. So back on the cap server, we see that the file copied over, and we can give it execute permissions by typing in chmod +x and then linps base. And we can go ahead and run that. This script will look through the stuff that we already tried to look at manually, as well as a whole bunch of other useful information. We can see that the script already found a potentially vulnerable version of sudo, which we can definitely take a look at. Here we see it enumerated the cron jobs, which we did earlier. We can take a look at the user information. It checked the ID of the Nathan user, gathered information about all the other users and groups on the system. And unfortunately, other than that potentially vulnerable version of sudo, it doesn't look like there was any other PE vectors that linps could find. But since sudo 1.8.1 was detected, I did look through ExploitDB and found this potential privilege escalation exploit. Just to save time in the video, I went ahead and ran this exploit on the system, and it was unable to exploit the vulnerability. And that is because the current user needs to have privileges to run sudo edit or sudo-e on a file as root, which in this case we do not. And this leads us to the next thing on my list, which is Linux capabilities. Linux capabilities are a security feature in Linux that allows specific privileges to be granted to processes or programs, allowing them to perform specific actions that would otherwise be restricted. So basically this just allows for more fine-grained control over your programs and what permissions they have, instead of having to create different users and groups and granting them privileges instead. So we can enumerate all existing capabilities by using the following command here. This is basically looking at all the different locations where binaries can be, making sure that the type is file, and executing the get cap command, which is going to get the capabilities of all those files. So after running that, the first one is especially interesting. We see that Python 3.8 can be run with the capability of set user ID. So if we can figure out a way to set our user ID to the root user, we can probably execute Python as the root user and escalate our privileges to root. And this can easily be done with the OS library in Python. If you're not that savvy with Python, you can ask ChatGPT how you can use the set user ID capability in Python to escalate privileges. But as a security professional and a penetration tester, I do highly recommend that you get familiar with Python and writing Python commands, especially with the OS library, because a lot of exploits that are written in Python are going to be using this library. It's going to be very helpful to be able to read and also write in Python. But if you're lazy, you can just throw this into ChatGPT or search for it online, and you will find a command similar to this one. So basically we're executing Python 3.8 and then using the -c argument to issue a one-liner command where we import the OS library, set our user ID to 0 or root, and then execute a bash shell. So hitting enter, we get that pound symbol, which means that we are root. And we can confirm that by typing in who am I, if I can type it right, and we see that we are the root user. So if we cd into the root directory and list all of the files, we see that we have the root.txt file here, and we can go ahead and cat that out. And there you have the root flag. And then once you've submitted that, you have completed the cap machine. Thanks for watching. If you enjoyed, make sure you leave a like and subscribe for more ethical hacking content. Let me know if you want to see more capture the flag walkthroughs or breakdowns in the comments below, and join my Discord if you haven't already. Alright, that's it. See ya.